Good, whatever time it is you're doing math. All right, today's or tonight's lesson is going to be about conversion factors. Now, before, when we were busy doing all of these different measurements, these different tables, and finding some patterns here, we're going to put some of them to good use in being able to convert easily from one form of a measurement to another form of a measurement. What I'd like you to do, since you can't write in your book and underline conversion factors and put all sorts of sunshine around it, is to write that down, and let's define what a conversion factor is once and for all. Now, this conversion factor is a rate that equals 1. What does that even mean? Oh, that means if you had two things, say like a meter, and you knew it equals about 3.28 feet, and you said, what is 1 meter divided by 3.28 feet? Well, that's silly. That's 1, because 1 meter is the same thing as 3.28 feet. Or 3.28 feet is the same as 1 meter. Now, what this means is that you can take any number and multiply it by something that's 1, and the number will stay the same, or the value will stay the same, but the number will change, and it'll get a new label. I'll show you what this looks like. I have a feeling we've done these before, but you'll have to correct me when I'm wrong later. So we have converting between systems. Now, it's nice to be able to go between inches and centimeters, or between metric, or US and metric. And in order to do that, we have a fancy-pantsy conversion factor. Now, if you see here, they wrote that 1 inch is the same as 2.5 centimeters. So what they did is they multiplied 20 centimeters by this conversion factor. Now, I want you to notice the very interesting way they set it up. Any number by itself is always on the top in a fraction. So you can just assume that. Now, you see how they wrote this conversion factor with inches on the top and centimeters on the bottom, and there's this red slash that goes through. Why would they do that? Well, interesting. If you have centimeters over centimeters like they have here, they cancel each other out, and what are you left with? Inches. So what all you need to do in this these problems is, once you get your conversion factor set up with the label you want to cancel on the bottom, all you have to do then is the straight math. And what they did here was 20 centimeters divided by 2.54 centimeters, and that gives you 7.87. If you notice here, they used a method 2. I don't like this method 2 as much. It's sort of confusing. I'll mention what they do real quick. They say, so they set up their conversion, and they have inches on top with both of them. You see that here. And then they have centimeters on bottom for both of them. On one side, they have their conversion factor right here, and with inches on top, centimeters on bottom, and then they put their unknown x, what they're trying to figure out what this is in inches, and then our known on the bottom, centimeters. So you just keep everything lined up like that, and then you do some algebra. If you have x divided by 20, in order to get rid of 20 or move it, you would multiply both sides by 20, so that gets canceled out, and you're left with 20 divided by 2.54. Not my favorite method, so if you'd like to use that in the future, sort of let me know, and maybe we can work it out together. Now, if you see here, I've written all these handy-dandy conversions for you already. 1 quart, and this first one equals 0.95 liters. I'll help you set these up. Now, if we want to go quart to liters, we'll have our 10 QT written, then times our conversion factor. I have a line because we're going to have a number over a number. Are we going to have quarts on the top or bottom, you might say? Well, if we want to cancel out quarts, we need to have 1 on the top and 1 on the bottom. So let's put quarts on the bottom so it can cancel out. We have 1 down there, and then we have 0.95 liters on the top. Now, what's fun about this is when it's said and done, quarts cancels out, and you're left with 10 times 0.95 and then our label that is left over here is liters. So do that on a calculator and you can write down your answer. For this next one, we'd have 4 kilometers and then times our conversion factor. Again, we draw a line. We want to cancel out, that's km. We want to cancel out kilometers, so let's put that on the bottom. Start over. So here we want to convert 4 kilometers to miles. So we have 4 km times our conversion factor. Again, we put a line. We want to put what we want to cancel on the bottom, km, kilometers, and miles on the top. Because no matter what happens, kilometers divided by kilometers goes away. And we're left with miles as our label. So we have 1 kilometer on the bottom, 0.62 miles, 0.62 times 4. And you can tell me what that equals in miles. Number 3, starting to get the habit of this now. We have 18 inches times our conversion factor. Draw the line. If inches is on top, we want to cancel it out. Let's put inches on bottom and centimeters on top. So when all is said and done, you're left with centimeters. So we know that 1 inch is the same as 2.54 centimeters. And you can finish off the math for that one. Last one, I'll help you set up 84 lb times, that's a little times there, because all of this, remember, is over 1. And we multiply it by something that equals 1. How crazy weird is that? 1 lb, on the top, 0.45 kg. So pounds cancels out, and you're left with just kilograms. So just like we can convert measurements like length or things like volume, like liters, we can also convert rates, a rate of change. Now, here they says convert the pumping rate of the human heart to liters per minute. So on the left here, you'll see it pumps 5 quarts of blood per minute, but we want to do this in liters per minute. So if you write out 5 quarts per 1 minute, as you see here, times our conversion factor. We want to get rid of quarts, so we write a conversion with quarts on the bottom. See how 0.95 liters is the exact same as 1 quart, so that's essentially multiplying by 1. Once you cancel out your units, you're left with liters per minute. So that's only when changing 1 unit. Sometimes you need to change 2 units. So if you'll see here, this zip line currently says that it's going to 15 miles per hour, and they want to change it to feet per second. So they have the original 15 miles per hour written down here, and then we have our conversion from miles to feet. You want to cancel out miles, so miles is written on the bottom. So we have 5,280 little tiny feet in 1 mile. So that's on the top being multiplied. And then we have to go from hours. You see how hours is on the bottom. So a conversion from hours to seconds is, you see here, 3,600 seconds for 1 hour. So they wrote that conversion factor there as well. So in between here we have multiplication and multiplication, tons and tons of multiplication by these fractions. So they simplified some things, meaning that they got rid of those parentheses, so you're left with 15 times 5,280 little tiny feet in a mile, and feet on the top. And on the bottom, all we're left with is 3,600 seconds. And they do some fancy-pantsy math, you end up with 22 feet per second. We've gone from miles per hour to feet per second. Now for these next 3 on your owns, I'll help you set these up, is we have an oil tanker is leaking oil at a rate of 300 gallons per minute. Convert this rate to gallons per second. So gallons gets to stay the same, but we just need to get rid of minutes and turn that into seconds. I'll write some conversions here. We have 300 gallons over minute We have to multiply it by something that will get rid of minutes. That means minutes is on the bottom. We need minutes on the top of a conversion. Now, there are 60 seconds in 1 minute. We want to end up with seconds. So 60 seconds per 1 minute. And all you have to do is do the math and simplify this, because you'll end up with gallons per second. Gallons on the top, and then per 1 second on the bottom, because you're dividing 300 divided by 6. 6 here, we have a tennis ball travels at a speed of 120 miles per hour. Convert this rate to feet per second. We'll essentially do exactly the same as we were doing earlier up in the example problem. And you'll realize that the only thing that changes here is, instead of 15, you can write 120 and set up that whole equation. So that's being able to use an example to your advantage. In fact, this 15 right here, write 120, get out your calculator and do some good math. Last one here, 7, I'll help you out with. We have a kiteboarder travels at a speed of 10 meters per second. Convert this rate to kilometers per minute. So we have 10 meters per second. Now we need to do some converting. So let's worry about meters first. So we'll write our conversion up here. We know that 1,000 meters equals 1 kilometer. Kilo is 1,000. So we need to put 1,000 meters, and then on top we can have 1 km. So when we do our math, meters divided by meters disappears. So we also need to convert seconds into minutes. So we know that there's 60 seconds in 1 minute, and we want to get rid of seconds. So seconds on top, minutes on bottom. 60 seconds per 1 minute. So to simplify, this would look like 10 times there's a very important idea that I don't want us to pass over just because it's at the bottom of the page, and that is converting units for area or volume. Now to do area, you have to multiply the area by the square of the conversion factor. Meaning, if we know that, say our conversion factor was 1 foot over 12 inches, we are going from inches to feet, we'd have to square this whole business, because we're going from square inches to square feet. So that's like saying 1 foot over 12 inches times 1 foot over 12 inches. And that would look like 1 over 104, 1 square foot over 144 square inches. That's sort of what we're doing in your RAP journal. So we'll go over what this looks like. So turn to your next page. Here we see a painting fracture by Bennett Gibson. I don't know what or who that is, and maybe someday we'll all care. Has an area of 2,880 square inches. What is the area of the painting in square feet? So we just have to do a little conversion. We have that large number, and then we have to times it by our conversion factor, but it's squared. A little square right there, which means 1 over 12 times 1 over 12, which is 1 over 140, 1 foot squared over 144 square inches. That means square inches cancels out, square inches cancel out. We're left with square feet, but not before we simplify by doing 2880 divided by 144, which simplifies down to 20 feet. That's nice. Volume gets even screwier, because you have to cube things. By cubing things, that's the same as saying 100 over, so 100 cm cubic centimeters over 1 cubic meter is the same as saying 100 over 1 times 100 over 1 times 100 over 1. So 100 times 100 times 100, which is 1 million cubic centimeters, is the same as 1 cubic meter. If you think about that, if you had a bunch of little dice and you were to get the line them all up so they're a meter long, so that's like kind of close to a yard, and you fill this whole box full of dice, it would be like 1 million little dice. So if 80 times 1 million equals 80 million cubic centimeters, that's how much 80 cubic meters is worth, or is in cubic centimeters. Last two problems of the night. I told Lacey this would only take me not very long because I still got to edit it. So, it is a painting busy market by the Haitian painter Frans Pearson, unless anyone else can tell me how it's actually said, has an area of 6 square feet. What is the area of the painting in square inches? I'll help you set it up. So we know that 1 square foot equals 144 square inches squared. That's like saying if you had a little square foot drawn here, and you know one side is usually 1 foot, so 1 times 1 would just be 1 for square feet. But if you convert that to inches, one side would be 12 inches, so 12 times 12 would be 144 square inches. Now our conversion, we're going to go 6 square feet. And how do you know if it's the top or bottom? Well, feet is on the top and we want to cancel it out. So we're going to, whatever is square feet, put it on the bottom, and inches is what we're going to be left with on top. So 144 and 1. So do 6 times 144, and that gives you your answer in square inches. Last little one is the volume of a pyramid is 50 cubic centimeters. What is the volume of the pyramid in cubic millimeters? Whew. So it's sort of a tiny pyramid, and then they're giving even tinier measurements to deal with. So we know that 1 centimeter equals 10 millimeters. But remember, in order to do the volume of something, it would have to be 1 cubic centimeter equals how many cubic millimeters? So that's like saying 10 times 10 times 10, 3. So if you do 10 times 10 times 10, it's 1, 2, 3 zeros. That's the same as 1,000 millimeters. So let's set up what our conversion factor would be. 50 cubic centimeters times, we want to get rid of cubic centimeters, that on the bottom, and on the top we'll have our 1,000 cubic meters, or sorry, cubic millimeters. So do 50 times 1,000 and you'll have your answer. I'll see you in class.